Hello everyone. Yes, today I will talk a little bit about LLMs security, and definitely I won't try to sell our product to you, but I will try to share with you some insights from our latest work. I'm Miloš Božić, CEO and co-founder of Pyxero.ai. We started as a service and consulting company, but nowadays we are more focused on AI system security. We're developing a platform for automated continuous red teaming penetration testing, especially for LLMs and agentic systems. Let's start with prompt injection as one of the most common technique of attacks. The formal definition from prompt injection attacking technique is that involves manipulating model responses through specific inputs to alter its behavior. This technique is first on the OWASP AI security risk list. And also, we can say that it's black box attacking technique because you can attack one system without knowing what is that system really. Is that a simple LLM? Is that a multi-agent system, or is that a RAG system? Also, this attacking technique is very often because you don't need some expertise from AI or ML to use it. And here you can see, I will show now you few most common patterns of prompt injection attacking technique. First one is direct override. Attackers try to use explicit commands to ignore instruction. Then system impersonation. Attackers try to mimic system or some admin message. Hidden injection pattern, where attacker try to inject harmful request through some secondary task over primary task. Authority invocation. Attackers claim that has advisor or some developer status. Unicode manipulation. Usually use some special characters to try to confuse LLM model, and multi-language attacks where attacker try to use some other language which is not native language for LLM on which LLM is trained. Jailbreak attacks technique. People usually think that that's totally different attacking technique, but formally jailbreak is a form of prompt injection, and formal definition is that's prompt injection attack where the attackers provide inputs that cause the model to disregard its safety protocols centrally. Jailbreak technique has also few most common patterns. Most often is character roleplay, where attackers try to introduce some fictional character with some story, and usually that is do anything now or done character. The second is hypothetical scenarios. What if context to bypass restriction? Token manipulation. Attackers try to manipulate the tokens on the prompt on the token level, not on the word level, and in that way try to confuse the model. Base 64 encoding or some other type of encoding, where simply attacker try to encode the prompt and try to confuse the model. Pseudo commands or program-like syntax, and token prefix bypasses, where usually attacker tries to use special tokens for that LLMs, manipulate them, and try to confuse the model. And here is a few examples of generated attacking vectors with our attacking vector generator engine. This is one of the first version of our generator engine, and now we have more advanced, but in this case we use that data which we generate with that version. The first one is example of jailbreaking technique with the character role play pattern across harmful contact policy topic. Second example is again jailbreaking technique with combination with character role play and Unicode manipulation pattern again across harmful content policy topic. And the last one is the prompt injection attacking technique with Unicode manipulation pattern across intentional misuse policy topic. This is only examples, and I show pretty short injection prompts and jailbreaks here, because usually attacking prompts are much bigger. Let's say something about our testing environments. We have two test environments. The first one based on the source of our attacking vectors. The first one is prompt injection and jailbreaking. This is our attacking vectors which we generate with our attacking generator. We tested across 11 topics. The list of the topics you can see on the right side. And in total we used 1,790, I don't know what we did, 793 examples. The second test environment is community attacks vectors. Here the main source of attacking vectors is the internet, where we collected publicly available attacking vectors. We use a little bit different policy topics to test. We used 13 topics, which you will see a little bit later. And in total, we use 1,400 attacking vectors. Everything multiplied by 3, because we count successful attack only if one attacking vector succeeds 3 times. The testing models, 4 models from the GPT family of the models, and 9 open source models in case, a few LLMs, Queen, Mistral, and DeepSeek V3. Okay, let's see how we set up that simulation. We want to simulate finance assistant bot, and for that case we have to define a base system prompt. Here you can see, let's say, more template of that system prompt. This is not the complete system prompt, because that prompt is much bigger. And here we give a structure to bot how to behave, define the role, and propose his purpose. And here are the results for this with this testing with the base system prompt. The first column is overall score or safety score. We use that simple metric, that's the percentage of the successful attacks, and of course smaller value is the better. The same score for all individual policy topics across each topic. Then we decide, okay, let's try to repeat the test, but to upgrade our initial base prompt. And we follow OpenAI recommendation for safety and security, and decide to add this policy add-on to our base system prompt. This is the beginning of that prompt. The prompt is very big, and this is the end. You see, we tried to put instruction for assistant bot how to behave in the case of prompt injection, context leakage, jailbreaking attempts. repeat the testing, and results are here. Now we have two columns, policy and base. Policy are results from using system prompt with policy, security policy, and in base column you can see previous results with only with base system prompt. You can notice that for all models we got the better results, better safety score. For some models, especially GPT family of models, the results are pretty good. And we can expect that because we follow official open AI recommendation, safety and security recommendation, how to design system prompt. DeepSeek, interesting is that DeepSeek is behave very similar to with the GPT family of models. Community crafting attacks, that's the we use for in that second testing environment. We collected initially 1,500 prompts, but after filtering we use 1,400 prompts are collected with from social media platforms and forums. We have much bigger database, but we have to limit the size of the test set, and this is only the reason why we use a much smaller data set. Here is the example, example of the manually community crafted attacks. This is the example of jailbreak with character role play, and the character is doing anything now. You can see how attacker tried to give different instruction to assistant to not to bypass security policy and to give another role to the bot. Another example, the first one, is jailbreaking with hypothetical scenario, not done character little. The name of the character is a little bit different, but the purpose is the same. Below is the jailbreak attacking technique with pseudo programming like commands. You can see that attacker tried to use some fictional programming language and tried to in the programming language structure try to inject some requests. This is only the part of attacking prompt. The prompt is much bigger. Here, let's look a little bit this list with open AI security and safety policy topics. And example of the questions. This is more from the business people. Example of the questions for each policy topic. The reason red questions simply look like not legit on the first. It's okay, but green question usually for most of the people may look like totally legit, and the people or users expect to get the answer on these questions. And that's the problem, because formally by the not only OpenAI security safety policy, this is forbidden. And you have the problem that on one side you want to develop a really performant, business performant assistant bot to be useful for the user, but on other side you have to protect the same user not to get answer on this kind of questions. And this is why it's very hard to make useful assistant, to be useful and protective at the same time. And here is an example using, now here we use system prompts with policy, and attacking source was community collected attack vectors. Of course, again, the GPT family models are the best one. From the open source model, DeepSeek has the best results from open source group of models. And Financial advice and economic harm policy topics are pretty critical because we have finance advice finance system bot and want to help user with on that topic, but again we have to protect that user, and it's obvious that our bot is confused. This is the final safety leaderboard. Here we rank all the models based on the bot's safety scores for bot testing environment. It's clear that GPT models are pretty good, and DeepSeek V3 is the best model from open source group of models. Yes, here I want to mention one important thing, maybe you didn't notice. For example, it's not fair comparison because for GPT family of models we use OpenAI API service, and when you use OpenAI API service, all GPT models have a few security layers. Officially, they didn't tell that to you, but they want to protect you, not to ask some crazy questions. Compared to tested open source models, which are totally bare metal models here in this case. Yes, let's say something a little bit about protection measures, essential protection measures, which you can do by yourself and do instantly. First, start thinking about security from the beginning. Don't wait to fine-tune your model and put it in production. That include get security policy, safety security policy of your selected LLM, check model source provider, and inform about which data and how they train that model. Second thing, you saw results. It's very important to craft a good system prompt. That means that you, in your system prompt, you have to include security and safety instructions, and it's pretty easy modification. Again, if you fine-tune, pay attention to training data because you want to increase business performance of the model, but also you have to think about safety security performance, and in that case you probably need to add security data for fine-tuning. Some more advantage gradual strategy. The first one is the simplest, input and output pattern-based detection. For example, you want to detect on every input and output to detect, for example, spatial tokens, which you can see very often in attacking vectors. High-powered security classification, much advanced type of filtering. For example, you use the other LLM model trained specially to detect to tree detection, or you can make some anomaly detection system based on vector similarity and check every time with your collection of your known data or database of attacking vectors. The last one is the most complicated and usually with big cost, that you can do parallel processing with two or few LLMs with different architectures, and compare their outputs to detect manipulations. And that's it. I hope that I shared with you some useful insights about LLM security, risk, and mitigation tactics. Thank you.
So, what are you selling? You promised you will announce that you're selling something. What is Pyxero? What are you doing?
No, we are early stage startup at the moment. We started as a service company specialist for customized solutions. But now we see the opportunity, we saw the opportunity and trying to focus on developing now that platform where you can use, automatically use red teaming penetration testing for your LLM and later agentic systems, for example.
Okay, so you would build in the system that will check the harmful outputs, basically.
No. We are not doing guardrail part. This part for guardrailing, that's only recommendation what you can do. The first thing you have to do some risk assessment. And for that, it's the best thing to do some kind of red teaming penetration testing. In the case you can find a red team and pay them to do that for you, but we're trying to automate that and to make platform that you can do by yourself, or even to automate when you do some fine tuning or any change of your model, you have to do again to test is everything like you expected.
Okay, so basically you find any vulnerabilities.
Yes, that's the first stage, yes. Sorry, go.
Hi. Do you have any experience with pen testing reasoning models, as there are no reasoning models in the...
No, we focused on let's say, we got feedback from the data sanity team. They said what they maybe wanted to see, and we use feedback from our business clients, and this is not all the models which we tested, this is small part.
Okay. I was just wondering on the numbers on the reasoning models.
No, we didn't do special tests for, especially only for reasoning model, yes. This is only this is the base for security, because the next level you have to think, for example, for agentic systems, how to track that of agentic system, then on RAG systems. Yes, this is very basic thing. Sorry?
Two small questions. One is, from your point of view, why do you think like the full focus was changed from checking output to checking input? For example, in search engine, if I pass all these queries that you suggested, so I will get some output in Google or in Bing and everywhere. Maybe Google restrict to provide some websites which has harmful content, but the input itself is valid, ever like this illegal request. But in LLMs, you and I think everyone like around talking more about how to prohibit an input itself.
You're talking about guardrail techniques.
Yeah.
Okay, as I said, our focus not on guardrailing. We did something, but I cannot say that I'm expert on guardrailing. Here, the idea is to test open source models, because we have a lot of clients who want to use open source to shift production from, for example, some GPT family of models on open source model and run that in some on-premise in their data center. And we tested, usually at the moment, most requirements came from that side to test how, this is why we, for example, give comparison with GPT family of models. From the business side, it's much easier to explain to someone the difference. From security perspective, it's usually also from the business performance perspective. This is why comparison, for example, from GPT family of models.
Do you have some examples in your mind when this prompt injection provides real harm for business? Or something
I can tell you only what you can read also on the internet. There's a lot of stories that how some use some prompt injection to inject some assistant bot for some European financing institute and things like that. Officially, I'm not sure that someone will tell directly, oh, we are prompt injected and have our problems and we have data leakage and things like that. To be honest, that's a moral story for now, and there is probably a real examples, a lot of real examples, but nobody wants to talk directly about that.
Thank you. We are out of time for the questions, but we will be able to finish.
Okay.
Continue asking you after we finish this.
Of course, thank you.
Thank you.
Thank you all.